Hello grade 8 students! For today, we will be discussing types of polygon. In today's lesson, you should be able to illustrate different kinds of polygon and identify the number of diagonals that can be drawn from each. But what do we mean by polygon? When we say polygon, it is a closed plane figure bounded by line segment called sides. Each segment intersects exactly two others, one at each endpoint, and no two segments with common endpoint are collinear. In this given, we have examples of polygon. On the other side, we also have a non-examples of polygon. So as you can see, there are some shapes wherein it is not closed, and there are some shapes wherein the corners are curved, and there are some which are the points are collinear and the line intersect at more than 2 points. So these are not called polygon. Now there are names in polygon. So if that is a three-sided polygon, we call it as triangle. If that is a four-sided polygon, we call it as quadrilateral. If it has 5 sides, we call it pentagon. Next is hexagon, heptagon, octagon, nonagon, and decagon. Our ruling, if it is more than 11 or 12 sides, we can name it as 11gon, 12gon, 13gon, 43gon, and the like. So what are the parts of a polygon? Let's proceed first on naming. How can we name a polygon? We can use the capital letters found on the corner of the illustration or use any three non-collinear points. On the given figure at the side, we can name this polygon as polygon penta because the vertices are points P, E, and N, P, and A. This is called polygon penta. Next is vertex. Vertex is a point where each pair of the sides of a polygon meet. The plural form of vertex is vertices. So these are the intersection of our two segments. So the vertices here are points P, E, N, P, and A. Next is consecutive sides. So these are two sides of a polygon that share a common endpoint. So we have segment PE and segment EN, segment EN and segment NP, segment NP and segment PA, and segment AP and segment AP, and lastly, segment AP and segment PE. If we have consecutive sides, we also have consecutive angles. These are two angles whose vertices are endpoints of the same side. So the two consecutive angles here are the following: angle P and angle E, angle E and angle N, angle N and angle P, angle P and angle A, angle A and angle P. We also have diagonals. Diagonals is a segment joining any two non-consecutive vertices. So the diagonals here are, the first given is the diagonal PP, next is the diagonal EA, diagonal PN, diagonal NA, and lastly, the diagonal EP. So here we have 5 diagonals. So we have two kinds of polygon, the convex polygon and the concave polygon. First, let's discuss convex polygon. It has no interior angle greater than 180 degrees. It has no inward pointing side. So the examples of convex polygon are this. In the contrary, we have a concave polygon. It has one interior angle greater than 180 degrees. So these are example of concave polygon. So as you can see, there is an inward pointing side. So this is under concave polygon. We also have two types of polygon, the regular polygon and the irregular polygon. When we say regular polygon, it has congruent sides and interior angle. So we have here a square wherein the angles are congruent. We also have here a equilateral triangle wherein all the angles are equal or congruent and the sides are all equal. So these are example of regular polygon. In the contrary, we also have irregular polygon. It does not have congruent sides and interior angle. So an example here, we have here a scalene triangle and a rectangle. So as you can see, even though it has the same angles, its side is not congruent. On the triangle, even though we have two congruent angles, there is one different interior angles. And the measurement of the sides of the triangle are not congruent as well. So this can be under irregular polygon. Now let's focus with diagonals. Earlier we discussed that when we see diagonals, it is a segment joining any two non-consecutive vertices. There are two kinds of diagonals. Diagonals from one vertex and the total number of diagonals. These are the diagonals that you can connect with any non-two consecutive vertices. So to find the diagonal from one vertex, we have a formula n minus 3. So for example, if we have a three-sided polygon, 3 minus 3 is 0. If we have a four-sided polygon, 4 minus 3 is 1. Therefore, in a quadrilateral, there is one diagonal, and so on. However, when we talk about the total number of diagonals, we can make use the formula n times the quantity n minus 3 divided by 2. So in this given, if we have a triangle, n minus 3 is 0, multiplied to 3, which is our n, that is 0 as well, and 0 divided by 2 is still 0. Therefore, there are no diagonals in our triangle. Now, if we have a quadrilateral, we can have two diagonals. Why? Because 4 minus 3 is 1, 1 times 4 is 4, and 4 divided by 2 is 2. And to find the other diagonals, here are the answers. Now, let me ask you a question. If the polygon has 36 diagonals drawn from one vertex, then how many sides does the polygon have? In this given problem, it was flipped. The given is the diagonals and the missing side is the sides of the polygon. So we have here the formula of diagonals from one vertex. B is equal to n minus 3. We have here a given which is 36 diagonal. So we can substitute 36 with B. So we will have 36 is equal to n minus 3. We are looking for the value of n. So we just simply combine like terms. We will have n is equals to 36 plus 3 or simply 39. Therefore, the number of sides of a polygon with 36 diagonal is 39. Now, it's your turn. Draw the following figure. Pause the video for a while and I will reveal the answer afterwards. So here are the answers on our previous exercises. For number 1, draw polygon log. 2, draw regular hexagon. 3, draw a convex pentagon. And number 4, draw a concave heptagon. That's all for today. Thank you very much and do not forget to access your paper accounts for a short assessment. Don't hesitate to ask Sir Alex and Miss Ria if you have further questions. Thank you and God bless.